Hey everyone. This is a problem that requires more critical thinking skills than it does math, which will probably make a lot of you very happy. It might make some of you not so happy though. But let's go with part A, which asks, does a mirror show you as being older or younger than your true age? And this question might seem weird because you'd think that if you're looking at a mirror, you're just viewing an image of yourself as old as you are. But the key thing to understand here is that technically, what you are really seeing is the light reflecting off of you, hitting the mirror, reflecting off of that, and then reaching your eyes. The key thing to understand here is that the speed of light is not infinite. Light doesn't propagate immediately. It still has the speed of light has a finite value, which means it still has to take some amount of time to reflect and travel between you and the mirror and then back to your eyes, no matter how fast that is. So, even though the difference is very, very small, technically what you are seeing when you look in the mirror is a very, very slightly outdated image of yourself from the past, basically. So the correct answer to part A of this problem is that you are actually seeing a younger image of yourself. It shows you younger than your actual age. Part B of the problem is kind of a follow-up to this that sort of addresses that and asks you to come up with an estimate for that age difference. And remember, we are expecting it to be very small. But the question is also very open-ended, because we're not given any values for it. We're just kind of asked to pick something, which is probably fine because we're also only asked for an order of magnitude estimate, which means the only number that the problem's asking for is a number in the form of like 10 to the power of some exponent. So we're free to just kind of choose whatever. I'm specifically going to go with kind of a range that you typically expect people to be looking at the mirror at. So I'll say, for the sake of argument, that we're looking at a mirror at a distance of about 40 to 50 centimeters. So if this is a person standing somewhere, and then they're looking at a mirror, what's happening in the time that what's happening as they're looking at the mirror is that light is traveling from you to the mirror and then back to your eyes so that you can see it. If we want to find the time difference, then we'll have to analyze the movement of the light just using the same kinematics that we've been doing since Physics 1. And we'll pull up the speed formula for this. So the speed of something is, of course, equal to the distance divided by the time it took for it to travel that distance. In our case, however, that velocity, that speed, is going to be c, which is the speed of light, 3.0 multiplied by 10 to the power of 8 meters per second. The d is going to be whatever we estimate it to be, but keep in mind that since the light has to travel from you to the mirror and then back, for our purposes, it's actually going to have to be traveling that distance d twice. So I'm defining d to be the distance between you and the mirror. And then, of course, delta t is what we're trying to find. So we algebraically solve for delta t, and delta t, the change in time, is going to be equal to the distance traveled divided by the speed. But like I mentioned earlier, for our purposes, the distance is actually going to be 2 multiplied by the d I labeled in the diagram, and the speed we're dividing by is c. So, like I said, for the sake of this, I'm going to say that we're looking at a 40 centimeter difference. That's going to be 2 multiplied by 0.4 meters divided by the speed of light, 3.0 multiplied by 10 to the power of 8 meters per second. And if we put this into a calculator, then we find a value of about 2.7 multiplied by 10 to the power of negative 9 seconds, which is a very, very small period of time. Though, of course, the problem asked for an order of magnitude age difference, so I'm specifically just going to circle the part that says 10 to the power of negative 9, since that's the order of magnitude. Now, it's probably a good thing that they only ask for an order of magnitude estimate, since if you play around with the values a bit, and you choose different values for d, ranging from around 20 to 30 centimeters up to about like a little over 1 meter, all reasonable distances for you to be looking at a mirror at, you find that you generally get the same answer, because even though you get slightly different numbers exactly, the order of magnitude is usually in this ballpark, 10 to the power of -9. Of course, if you go really small, or if you go like 1.5 meters or larger, you'll probably get some slightly different order of magnitudes. But again, I wouldn't worry about that too much, because the problem seems very clearly phrased in a way to account for the fact that you might have different answers. So yeah, so that's really it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos like this. And if you have a request, leave a comment down below, and I'll do my best to help you out. If you have a request for a future video, or you just like to hang out, my Discord server and my Twitch page are both linked in the description below, so check those out if you'd like. But that's all for now. I hope you all have a lovely night. Bye-bye.